All right, you guys, this is Dr. Callahan for week 16 Tuesday for Algebra 2 semester 2. Welcome. Today we're going to go ahead and get started with your warm-up. So go ahead and pause the video and answer the following 3 questions. All right, that's enough time. So looking at this right here, does anybody know what is a missing answer for triangle number 3? It is 60. How did you get that? Yep, you got it. 5 and 3 and 2 is 30. 2 and 4 and 2 is 16. So 4 times 3 is 12. 12 times 5 is going to give you 860. Good job. I'm glad you got it. I showed this to my calculus kids like last period, and like every single one of them got it quickly. And then I showed this to my freshmen like first period, and like nobody knew what to do. So I was like, you guys will get there. You guys will think a little bit critically, later on. All right, you guys. So tomorrow is Wednesday. I will be updating your grades for this week. So if you have anything that you have not turned in from Thursday, Friday, Monday, and Tuesday, give it to me tomorrow because I will be updating your grades. 3 grades go into your grade book every single week. 1 for Math Excel for your 10 questions practice homework. 1 for your mastery for the assessment from Math Excel. And then the 3rd one is from all the stuff that you turn in class. Now, the 3rd one that you guys turn in class, I'm not even seeing like if it has to be like 100% correct. It's just, did you do the work? And as long as you complete it, you get a check plus, right? And when you guys sign in today, you probably already saw the checks next to your name. If you have no checks next to your name, it's because I haven't received anything. And if I don't receive anything, there's nothing for me to grade for you. So if you look at your roster, if you have not been to school and you've been absent, you usually get a 5. That's the curve. But if you have been to school, but you have literally turned in absolutely nothing and you have no check marks, you get a 55%. Now, if you do turn things in, but you have not completed 100%, you get 7 or 6. And then, of course, if you get your check pluses, you have an 8, 9, and 10, and that's the breakdown of your grades. Okay. As we get closer to the end of the semester, you need to understand that there is absolutely no curving in this class. I don't do it because 1, I have to literally pad and BS your grade, which I don't like to do because it's unethical. And 2, you're already getting a 50% curve. So, your grade is what you get. So just keep that in mind. Your safety grade is a 75%. Overall grade is going to be a 60 in case you fail the final. We're done with this one. So we're actually right here today for week 16. And if you look at this, we only have like 3 more weeks, you guys, after this week. And then it's finals and that's it. And then you guys become seniors. Last class, if you did not turn this in to me last class, you have a 0 until it is completed, or I should say 5 is what I meant, or 5.5 if you were here. So the first thing we did yesterday was we went ahead and revealed the table of exponential functions. Hopefully you guys know it was like an ice cream cone. And then the second thing that I had you guys do was you guys were supposed to match the exponential equation with the table and then match it with a graph. So these were the exponential equations, these are the tables, and these are the graphs, and you guys are using your calculators to do that. So today, we're gonna go ahead and get started on your materials for today. If you go onto your YouTube channel, you guys should have the video from yesterday, which I have not uploaded yet. So I'm actually gonna do that right now. Oh, you know what? I need to convert it first. Just kidding. All right. So then today we're going to start off with the properties of logs for day 1. And so week 16 Tuesday, log properties, introduction, day 1. You guys need to have your guided notes. Does anybody need the packet of their guided notes? If you do not have that, please come up. It looks like this. And you also need a TI-84 calculator. So we're going to go over our notes for that. I'm going to do a Desmos introduction to logs, and then I have a Padlet exit ticket for you guys. But you do need a TI-84 calculator so you know how to find the answers. Without a calculator, it's going to be kind of hard to figure it out because I'm going to introduce you guys to E, and you don't want to calculate E by your hand because you can't do it. So got to have a calculator. Oh, I will take that. Thanks. And I'll grade it tomorrow. So yeah, don't worry. All right, so if you guys have your notes right now, make sure you guys turn into the inside part of your guided notes, which is this page right over here. So let's start off with that. And if you're looking at your warm-up log and there's like a bunch of empty boxes, just go to the YouTube channel, look for the week and day, and then just pause the very beginning and then just fill those boxes out. Each of those boxes are worth 1 point. So in a total of 300 points is what you should have for week 19 Friday as we approach that day. All right, so let's go ahead and get started with today's stuff. So we initially started off with exponential growth. So when a quantity is increasing, 1 plus r is always going to be called the growth rate. Okay, so today I'm going to show you guys how we transition from exponential growth and decay into E and logs and why we use it. So for example, in 1990, the cost of tuition at a state university was $4,300. That does not happen nowadays. $4,300 at UNR maybe give you 1 class. It's expensive. I'm not joking. It's expensive. Like 1 graduate class, I should say. So it's like a master's degree class. But back in 1990, $4,300 will cover the entire semester. During the next 8 years, the tuition increased 4% each year, and it's still increasing every single year. So A, write a model given the tuition Y in dollars in T after 1990. So you're gonna have Y of T is equal to, so your initial value, remember A is always gonna be your initial value, and then your 1 plus R is going to be your multiplier, which is either growing or decreasing, or not growing, declining, I should say. So your initial value is 4,300. So then you're going to do 1 plus 4% is 0.04 to the T power. So then for B, we're going to use that same model to estimate how much is your tuition in 2020. So that was like 2 years ago at the beginning of the pandemic. Well, if it starts from 1990 to 2020, how many years are in between those 2 time frames? What is your T equal to? Yeah, it's about like 30-year difference, right? So how much is your tuition going to be for Y of 30 at 4,300, 1 plus 0.04 to the 30th power. So now you're gonna grab your calculator. And this is interesting because you guys are seniors next year and you're gonna, if you're gonna plan on going to college, it might be worthwhile to see how much college tuition is going up. So first thing I'm gonna do is I'm gonna just do 1.04 to the 30th power. So to the 30. Remember, you have to work from like the inside out, like PIMDAS, right? You gotta do the inside the parenthesis, which is 1.04. Then you have to do the exponent, which is 30. And then the last one you do is multiplication, which you're gonna multiply by 4,300. So enter, it's 3.24. That multiplier is like unbelievably high. Okay, most multipliers like 1 point something something. So that's pretty high. Times, now you have to times it by the initial value, 4,300. This is how much your initial value is going up. It's like 3 times because it's 3.24. So now your new one for this tuition is now $13,946. So tuition is now $13,946. And that actually sounds reasonable. At UNR, I can actually tell you right now, that's probably how much it costs 1 year at UNR. And I know you're thinking like, that sounds like a lot of money because like, if you think about it, you needed 4 years at UNR. So you take that times it by 4, that's how much it's gonna cost you to go to the state school. But if you look at some of the state schools, like in California, for example, they're not just $13,000 a year. They're more like $40,000 a year, which is even significantly higher. And I'm not sure if you guys know the difference between in residence versus out of residence. Like if you're not a resident of California or Oregon or anywhere else, because right now you're a resident of Nevada, you have to pay out of resident state tuition, which is twice as much as if you have in-state residence. So that's why it's always best that if you're planning on going to school, you stay in Nevada because you get in-state tuition. But also if you go to like somewhere like Oregon or something, you want to make sure you have like a power bill for at least a year in order to claim in-state residence, so you don't have to pay as much, okay? And I know you're like, well, that is just way too much money. But here's the thing. If you guys go to private schools, like, you know, not just the Ivy League, like there are private schools in Kansas, you know, that nobody has ever heard of before. Those private schools, they're starting at 50,000 plus a year. So it's very, very expensive. So I would say if you're going to go to school, you know, you can start at TMCC, get 2 years of worth at TMCC, which is a lot less expensive than UNR, transfer over to UNR, stay 2 more years at UNR, and you graduate with 2 degrees, one from TMCC and one at UNR. So that's one of the ways that you can kind of combat the cost. Another way is get grants and scholarships. Scholarship is strictly based on academics and talent, like sports, if you play an instrument. Grant is simply based on your income. Like, do you come from a single family household? Do you have a lot of brothers and sisters? And it's income based. So if you get the Pell Grant, which some people do get based on their income, then that covers everything that you need for going to UNR. Okay, so gotta start thinking about these things when you guys become seniors next year. All right, in January 1993, there was 1.313 million internet hosts, which is not that many. So this is back in 1993, you guys. I mean, nowadays there's like billions and billions. During the next 5 years, the number of hosts increased 100% each year, and I believe that. So write a model that's going to showcase the number in millions after 1993. So you're going to start off with y of t is equal to, you start off with your initial value with your multiplier and then to the t. That's your equation. My initial value is 1.13 or 1.313. Remember, this is in millions, so it's not just one, it's 1 million, okay? Your multiplier is multiplying by 100%. 100% in decimals is just 1. So it's just 1 plus 1 to the t. That's your equation. Or you can go ahead and rewrite it. So 1.313 times 2 to the t. So using this model, how many hosts were there in 1997? I mean, if you're increasing by 100%, I mean, I think that number is just gonna be too damn big. So how many years do you have between 1993 to 1994? Or I'm sorry, 1997. 4 years, right? And that's not even that many years. Like you guys are in 2022 right now. 1997 was so long ago. I'm like trying to think, where was I in 1997? I think I was in like elementary school or something. You guys you guys were definitely not born then. So yeah. So y of 4 is equal to 1.313 times 2 to the 4th power. So grab your calculator. Let's see if this is gonna break our calculator. I have a feeling that this is not gonna go well. So I'm gonna put 2 to the 4th power. That gives me a 16, and then times that by 1.313, and that's gonna give you 21 million. So you started off with 1.3 million, and now you have 21 million. But if I were to put this like in actual number terms, it's 21, comma, 008, comma, 000. So 21,008,000. I mean, in just those 4 short years, you went from 1 million to 21 million. So obviously, you know, people are definitely using internet a lot more. But if I were to go a little bit further with this, how many internet hosts do you have now? I mean, how many years do you have between 1993 and 2022? 29, that sounds good. So then I just go back to my equation. And if you don't want to do all of them over, that's fine. So just do 2 to the 29 power. That's your multiplier, which is absolutely crazy. Times it by 1.313. Can't push the dot here, 313. And now I don't, that's in millions, you guys. So we have to convert it. So that's 70. I can't even, like, hold on. I'm just going to screenshot this because this answer is just really crazy and big and I can't even figure that out. All right, so need like a whole new page for this. Stand by, I'm getting it there. Okay, so in 2022, this is in millions. Okay, so you have 704,911,507, and then this you have to go 1, 2, 3, 1, 2, 3. Okay, so it's 5, 1, 2, 3, 4, 5. This is how many you have, and then you're gonna go back with your decimals. 1, 2, 3, 1, 2, 3. I don't even know what number we're on anymore. This is in the millions. This is 100 millions. This is in the billions. I guess we're in the trillions now. 704,911,507,500,000 internet hosts in 2022. That in comparison to just 1 million back in 1993. So did the internet just completely blow out of proportion? Yeah, it did. But you know, that's just life, right? Yeah. I'm curious, like in another, I don't know, like 5 years or something, like when my kids are going to be like the teenagers and whatnot, like what is going to happen then? You know, like what's the new trend of this? Okay. Let's move on to the next part. Okay, now that we talked about exponential growth, awesome. We're going to go on to exponential decay. So when you talk about exponential decay, remember the quantity decreases, obviously. So instead of adding, you're going to subtract. And we went over some examples of when something might decrease. Like I think the number one thing is like the cost of your car when you drive off the car lot. Your new TV, right? Because that TV is going to depreciate in price. It's not going to go up. So 1 minus R is called the decay rate. So you bought a car that's $24,000, which is awesome. The value of the car decreases by 16% each year. 16% is equal to 0.16. So when I write a model for this, it's y of t equals, remember, you're going to start off with initial value, 24,000 times 1 minus 0.16 to the t. And of course, if you want to rewrite it by subtracting it, it'll be 0.84 the t. And notice like your multiplier, your b is less than 1, and that's how you know it is a decay because it's smaller than 1, obviously. If it's going to be bigger than 1, your number should go up. So how much is your used car going to be worth after 2 years? So I'm going to do y of 2 is equal to 24,000, 0.84 to the 2 power. And so with your calculator, we're just going to go ahead and put 0.84 squared, because remember, we're going to do PEMDAS, times 2,400. Or I'm sorry, 24,000. So your car is going to be only worth $16,934 and 40 cents. And that's after 2 years. Like you just lost $8,000 or $6,000 worth of your car if you buy a brand new value of a car. So sometimes people like to buy like used cars just for those reasons. Like the minute you drive your new car off the car lot, you already lost $500. That's like just a rule of thumb. And so, but you know, some people just like having a brand new car because it smells good and nobody has ever driven it. And chances are you won't have any problems with it, you know, so it's kind of like a vanity thing, I guess. But I have 4 kids, so it doesn't matter what new car I buy. It's going to be used in like a week after that. I bought a brand new 2016 Honda Odyssey, like the minivan with the sliding doors and leather seats. And I think it was like a month after that, I took my kids over to the Human Bean and they got like the chocolate smoothie there. And my little boy left it on the side of the car. And when I made a really sharp turn, that entire 32-ounce of chocolate smoothie dumped right below his leather seat. And I was just like, awesome. That's great. I'm like, I think my car just depreciated by like another $100 there. All right, let's take a look at number 11. So there are 40,000 homes in your city. Each has 10% of the homes are expected to disconnect from the septic system to connect to the sewer. So write a model representing the number of homes that still uses the septic system. I don't like that question. We're skipping it. Sorry, we're skipping it. All right, let's talk about compound interest because this is much better. It's about money. Few things. This is a formula for compound interest for when you put money in the bank and you want to know how much interest you're going to get back from the bank. A stands for final amount. P stands for the starting amount, like how much money did you put in the bank initially. Arch is the rate, and you have to put that in a decimal. And N is going to be how often. How often do you get your interest back per year? Oh, and there's one more. I don't have it here, but T equals time in years. Has to be in years. So if your T, for example, is going to be, and this is where it goes over here. Okay, so this is T. When T is not in years, okay, this is what it means. Annual means that it is just going to be once a year. Like they're going to give you interest once a year. Semi-annual, like when you go to a semi-annual sale for Bath and Body Works. I'm not sure, you guys probably have seen them. It's the one where they have the yellow ducks at the mall and everything is like 75% off. So how many times do they have that sale? It's a semi-annual sale. So it's twice a year, every 6 months. So that way, if you want to get a bunch of like leftover Christmas smelling lotions and body bath in February, you can and store it up for next year. Quarterly, how many quarters in a dollar? There are 4. And how many weeks are there in a year? How many weeks? Does anybody know? 52 weeks in a year. And then I'm going to add a few. If it's month, it's 12. And if it's daily, it's 365. Yes. 1, sorry. 1 right here. Oh, final amount. Final. You're welcome. So final amount is how much money do you get back after so many years you put in the bank? P is your starting amount. That's how much money you put in the bank initially. But the final amount is the one that you're interested in because it's like, I don't care how much money I started off with. I want to know how much money you're going to give me back after I leave it there for 30 years. Because that's the part that gets me excited is like when I put in $500 at a bank, you know, and if I get usually like 6 to 12% annual annual return, in 40 years, that $500 will probably grow up to be about $1 million. And you start off with but you have to put in there for 40 years, you know, so you can't touch that money. So yeah. But that's how you like retire off of. And right now you guys are really young, so you probably don't think about that. But the best time to start saving money is like when you're 18 and in your early 20s. And I teach province stats for seniors. So next year's province stats might be interesting for you. And we talked an entire quarter about financial math, like how to invest in the stock market, how much to put it into a 401k, etc. So that way you have enough money to retire off of. All right, so let's start off with $1,500. You're going to deposit this into an account, pays you 6%, and you want to figure out how much it's going to be after 3 years if the interest is compounded annual, quarterly, daily, okay? And when you're putting your money into a bank, you want to shop around because guess what? There's a lot of banks that want your $1,500. Some of them will give you a really good percent interest rate. Others, maybe not so much. So you definitely want to shop around and pick the bank that will give you the most for your money. So let's go ahead and try this. So what we're going to do is we're going to put this into that formula. And if you're like, what formula? It's this formula right here. So you guys have 3 different banks. Let's see how much they're going to give you back for your money. So here's your formula, and we're going to start off with this one with the following. For A, and I'm just going to separate this so that way you have a little bit of space. For the first one, we're going to do A is equal to $1,500 because that's what you're starting off with. 1 plus 0.06 divided by N is 1. So they're just going to give you interest once a year. So that's not great, but that's okay. Then 1 times 3. Quarterly, you're going to set it up so it's A equals 1,500, 1 plus 0.06, N is 4, 4 times 3. And of course, your last one is A is equal to 1,500, 1 plus 0.06 divided by 365, 365 times 3. All right, so now that we have that, grab your calculator. Let's try to figure it out. So remember PEMDAS, okay? So I'm gonna highlight it for you guys first. So PEMDAS means you work inside the parenthesis first. I'm gonna highlight the yellow part and I'm gonna write yellow part is first, okay? This piece right here, that's first. Then you're gonna do the orange part, which is the exponent. So I'm gonna write that second. And then the very last part is multiplication, which is right here in green. And I'm going to write that as third. And that's important because if you don't do it in that order, your answer is going to be wrong. So let's grab our calculator. And we're going to have 1 plus 0.06 to the 3 times 1,500. And the first one, you actually get, you know, about an extra $200. So that's not bad, you guys. I mean, you guys still get something. I mean, it's not great, but, you know, in 3 years, you're going to get $286 back. That's not bad. But I think you'll do better. So then let's go ahead and take a look at the second one. The second one is going to be 1 plus 0.06 divided by 4. You got to put the parenthesis, so you have to be careful with it, okay? 3 times 4 is to the 12th power times 1,500. That was not bad either. I mean, like it's, you know, you get a few more dollars, but not by significant much more, but, you know, still something. Okay, let's try the next one. The last one is compounded daily. And if I make a mistake, you guys, please let me know because I tend to make mistakes right around now because I'm hungry and I want to have lunch. But if I make a mistake, just let me know. So we're going to do 0.06 divided by 365, add it to the 1 that's inside the parenthesis, raise it to the 365 times 3. That's your multiplier, and we're going to times that by 1,500. All right, so then there are your answers for those 3 steps. Okay, so it doesn't change significantly. I think part of that is because you're only leaving it there for 3 years, and I feel like you really need to leave it in there for a lot longer. So I guess, like, what would this be if I decided to go ahead and leave this for like maybe 40 years? Like most people leave their retirement for 40 years before they retire. So let's try this with 40 years. If it's on an annual basis, okay, you'll just have 1 plus 0.06. Actually, no, it would be, yeah, 1.06. I'm going to raise it to 1 times 40. So it'll be 40 times 1,500. Okay, so in 40 years, you guys, your money from that first one is going to grow so much more. How much more exactly? Your money is now going to get up to 15,000. So this one, oops, let's see. In 40 years, take a look at that. Instead of getting just $1,700, you're going to get $15,000, okay, in 40 years. So the longer you put your money in the bank, the more money you will get overall, okay? All right. I'm going to go ahead and skip that one. We're going to move on to the next piece. Yeah. All right. Scroll over to this page right here. And actually, yeah, we'll start this one, and then I'll have you guys do the decimals. I'm going to introduce you guys to a new thing called E, and that E is called Euler's number. Euler also invented pi, which is 3.141578, blah, 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 so on and so forth. E is called the natural base, and on your calculator, it is equal to 2.71828. And if you're like, where is that E number on my calculator? So take a look at your calculator. Where do you guys see an E, you guys? Which button does it have an E on it? I don't know about you, but I think there's 2. There's one with the ln and there's one with a division sign. The one that you want in this class is the one with the division sign. So you hit second button and then division, and do you see the E right there? It just pops up. And then if you hit enter, that's the number that E is equal to. So make sure you know where that's located. All right, now let's go ahead and do some calculation with E. So first things first, number 1, e to the 3rd times e to the 4th. Well, you know that you just add them together. So that's e to the 7th power. Now grab your calculator because I want this in decimals. You're going to do second. And instead of doing the division sign, do you see how there's a 7 on top? This is where you're going to use the ln. Because with the ln, you have e to the x. And you replace that x with the number 7. And when you hit enter, it's going to give you 1,996.633. Okay, so then let's take a look at number 2. For number 2, you have 10 divided by 5, so that's a 2. And then you have e to the 3rd power and e to the 1 power. Okay, remember, you always move the smaller number. The smaller number is going to be a 1. So when you move it up, you have to change it to the opposite sign. So what's 3 minus 1? It's a 2. So then with your calculator, you're going to go ahead and type that in. So you're going to hit 2, second, ln to get e to the x, and then push a 2 right there and enter. And you should get 14.778. All right, for the very last one, this one you have a square on the outside. So what you're going to do with that square is you got to distribute it to the 3 and then to the e, okay? So they're going to have 3 squared e to the negative 4x times 2. So then if you think about it, 3 squared is 9. E to the 4x times 2 is a negative 8x. I don't want anything negative exponent. So I'm actually going to move this entire e down to the denominator. And if I move it down to the denominator, then I get a positive 8x. Because remember, when you move the exponent up and down the fraction bar, it becomes opposite. So my answer here is just 9 over e to the positive 8x. And since I don't know what x is, that's just my answer. I can't put it into a decimal because in order to do that, I need to know like x is equal to 2, and in which case I'll just do 9 divided by e to the 16th power. But I don't know that, so we'll just keep it as is. All right, I think you guys are now ready for graphing. So I'm going to take e, I'm going to take exponential growth and decay, I'm going to merge it together. But before I do that, I want to make sure we practice a little bit more with this. So grab your calculator, and I want you guys to give me the answer to 6, 7, and 8. And while you guys are doing that, I'll work on it too. So I just want to make sure you know how to use your calculator. All right, so if you have all 3 answers, your answer should be 7.38, 0.94, and 1.49. So when you insert that into your calculator, those are the answers that you should have. You don't have to have that many decimals, like 2 decimals is more than enough. So if you round it to the hundredths place, you're good to go. All right. I have about 10 more minutes of class. I'm gonna just do one more and then we will stop. So let's go on to number 14. So now you're gonna go ahead and graph this, okay, with E. So before we used to have like exponential growth and decay, but they're a lot more different than this. This one's a little bit different, obviously. So when I graph this, you're gonna use your calculator and we're gonna graph it by going to y equals for number 14. So y equals, and I'm just gonna put second ln for the E, x minus 2, okay, that's on top. But then you're going to use your little right arrow to move that thing down, and then plus 4 and graph. And hopefully your window looks a lot better than mine because mine is askew. So I'm going to change my window once it's no longer thinking. Okay, and so I'm going to change my window to just a traditional -10, which I can't because the stupid thing is right here. -10. +10, and then -10, +10 graph. All right, that doesn't look too bad. Do you see where your horizontal asymptote is? I mean, isn't it hitting that number 4 right there? Do you guys see that? Like it's not going below 4, right? So then what you're gonna do is on 4, we're gonna go 1, 2, 3, 4. We're just gonna go ahead and draw a line to let me know that my graph cannot hit that. So this is y equals 4. Horizontal asymptote is 4. So my graph does not touch below that line. And also, if you take a look over here, when you're looking at movement, doesn't it have a +4 there? So that +4 tells you that's your horizontal asymptote. So then with your movement, the 4 means 4 up. Now, which one's going to tell you whether you're going to go to the right or left? It's going to be that -2 with the exponent. So in this case, it's 2 to the right. And so we're just going to go to the right. 1, 2, right here. That point is where my graph is going to start curving up. And so if I were to draw my graph, it will look something like this. So it doesn't go below that, hit that curve, and it goes up like that. So those are the 2 points that you need to focus on. All right, so then we have some tables over here. So let's take a look at our table. Got 2 tables right here. First table I'm going to use is, let's just go ahead and put down 0, 1, and 2. Okay. So then what is your y value? Well, you're going to go to your calculator, get second graph to get your table. Okay. So when my graph is at, oh, sorry. Hold on a second. Actually, you know what? I'm not going to do, well, okay, let's do the table. I'm going to show you guys this way. So with the table, you want to start it at y equals e to the, actually, let's see, do I really want to do that table? E to the x. Okay, I'm going to start with the e to the x. So what I'm going to do is I'm going to go back to my calculator. Y equal, see, this one has like the one with all the transformation on it. I don't want that. I'm going to deselect it because I'm not going to use that right now. I'm going to go down over here to number 2 and I'll put e, which is second ln, to the x, and then graph that. So I'm just going to use the e to the x. So that's your parent function. Then go to second and then graph. And then once I get to second and graph, I can be able to see all of my equations right here. So when x equals 0 on your graph, do you see how y equals 1? So So I'm gonna put 1 right there. And then when x equals 1, my y value is gonna be 2.72. So 2.72. And then when my x value is gonna be at 2, my y value is at 7.39. Okay. Now, what I'm going to do is I'm going to put in the transformation. Okay, so your transformation is you go up 4 and you go to the right 2. So I'm going to put plus 2 on the x value and then plus 4 on the y value. So all you have to do here from now on is you just add it. What is 0 plus 2? 2. What is 1 plus 2? 3. What's 2 plus 2? 4. That is your new chart with the transformation of going up 4 and to the right 2. Hey, how are you doing? Oh, no problem. Yeah, on that card is perfect. Thank you. And then you're going to do the same thing with a y value. You're going to go y plus 4 is going to be a 5. 2.72 plus 4 is going to be a 6.72. And then 7 plus 4 is 11.39. And that's how you're going to fill out your chart. You always start out with the parent function, then look at the transformation. Thank you so much, Nancy. I know that was a lot of work. I'm sorry, but like, you know, algebra 2 is difficult, and I'm like, I don't want to not show you guys the difficult stuff to make it easy, because I feel like if anything else, it's doing you like a disservice because it's saying like you're not smart enough to do it, and I totally I don't agree with that. I know some teachers, they want to teach you guys the easy stuff, and I'm like, screw that. We're gonna go to the hard stuff. So we'll continue with this tomorrow, you guys. And so for your exit ticket today, you just need to go to the QR code, pick any 2 questions and answer that on the Padlet board. And that is your, that's all you have to do today. Tomorrow, we will go over the Desmos because I didn't have time today because I was like on a row and I want to make sure that you guys got all the information. And so you don't need to turn anything in today, but this is your last part, which is the exit ticket. For those of you guys on Zoom, I hope you guys have a wonderful day. I'll see you guys next time. Take care.